Hi, folks. My name is Asif Patani. I'm the VP of Products here in Finetta. I'll walk you guys through some of these slides here, and then hopefully we can have a longer conversation around the questions you may have for me. So the company Finetta, founded in 2008, we've been shipping products since June of 2011, so about 8 months now. 2 quarters of really good revenue here in multiple verticals. The exec team, all of us come from companies such as Cisco, Citrix, et cetera. We've been doing this for a long time, understand how to sell networking equipment, understand how to build high-performance systems. To date, we've raised $30 million in funding over 2 rounds from some very heavy-hitting VCs. So let me get into the meat of the presentation. So businesses spend a lot of time optimizing their overall infrastructure to reduce the cost of business. A key part of this cost reduction is, of course, DR strategies that key in on data protection. If you are offline, really you're not serving customers. Thus, DR is very important for you. And of course, if you lose data, you may not have the transaction records that you need to go back and incur revenue. These business initiatives lead to IT initiatives such as business continuity, DR consolidation, virtualization, and big data. And really for all of these initiatives, the wide data network is the key element and is becoming a bottleneck in many cases. The inter-data center WAN is typically too small for the enterprise's needs. That's the typical use case. Enterprises continue to deploy WANs that are really a fraction of the speed of the LAN. And when IT initiatives come to a head and enterprises decide to upgrade their WANs, they face yet another challenge. WAN upgrades are expensive and time-consuming, and enterprises are forever playing catch-up to the needs of the key business initiatives. Replication, for example, is growing at 45% year over year, which is staggering, and it's always a challenge for IT organizations to keep up with these kinds of growth rates. As a result, WAN resources are allocated in a tiered fashion, with some initiatives always left wanting of resources. Let me illustrate that point with 2 examples, and then we'll talk about the product. So first, a large financial services company situated 2 data centers, one on the East Coast, one on the West Coast of the continental US. The company storage architects determined that the distance between the data centers would provide complete protection if a major disaster were to strike. And they put in a pretty comprehensive storage replication project to meet these goals. The company deployed multiple 10-gigabit links between the 2 sites in an effort to make enough bandwidth available to meet all data protection needs. Unfortunately, the company was unable to meet its RPO goals, even though they had abundant WAN bandwidth in place. In fact, replication flows were periodically timing out because of the high latency on the WAN. And the latency impact was really, it was so bad that the WAN, even though they had multiple 10-gig links, they were utilizing effectively none of it, which is a disaster for that company. One more example, a cloud provider who's been using our products for some time, they are basically hosting, they started out hosting customer VMs in multiple data centers. And the intent was that as part of the service, they would provide a DR service for all the data that they store for the customer. They started out with 30 customers in 3 geographies and deployed multiple MPLS links between each side to meet the perceived data transfer needs. Unfortunately, they couldn't meet the data protection SLAs they promised to their customers because they didn't, either didn't have enough bandwidth or the distance between the 2 sites was too large to really utilize the bandwidth. The result for this customer before they deployed our solution was really a measurable hit to companies' revenues because they could not sign on more customers because they couldn't even guarantee SLAs for their existing customers. So that's where our solution came in, and we were able to help these customers. Let me talk about the product itself. The DMS is really the only WAN optimization solution designed to address these kinds of high-speed data protection use cases. The DMS is the first and only WAN optimization solution designed to exploit big traffic workflows across the inter-data center WAN. The DMS has been architected using merchant silicon and is really not designed using the standard WAN optimization paradigms of using off-the-shelf servers because those are really compute-focused approaches to solving problems. The high-performance networking approach we've taken for this system design, along with the multiple patents we filed around deduplication, allow us to scale to 10 gigabit speeds on the DMS without any loss in performance efficacy. The DMS can deliver 5 to 10x data reduction for enterprise WAN traffic, can guarantee priorities for critical traffic, can be transparently deployed in data center networks in minutes, and delivers a full return on investment for customers in well under 12 months. So, given the use cases I described and the product that I just talked about, one of the questions that comes up all the time is, why don't you think traditional WAN optimization solutions can address this problem? So the background is WAN optimization started out as a solution for the branch. Branches are typically low bandwidth sites, very far away, where some user is sitting on a computer trying to access a resource in a data center. The new problem enterprises are facing is more of one between data centers, and the interaction is between machines, and users typically aren't even involved in the process. But the killer app for solutions for Riverbed and other similar companies was protocol optimization for SIFs for file access or MAPI for email. The new killer app between data centers is really it's data mobility, and the biggest example of data mobility is for data protection. The traditional WAN optimization solutions, because they were built on these server-based architectures using x86 processors, they were perfect for application-specific development that was required for the branch, but they just do not scale for the inter-data center WAN use case. And there are really three primary reasons why they don't work, and the three things that are really missing in traditional WAN optimization solutions. Number one, acceleration at very high speeds per device. One single device, how far can it go? Can it go to multiple, multi-gigabit speeds or all the way to 10 gig speeds? That's a requirement that you must think about when you're looking at inter-data center WAN solutions. Second is per connection performance. How fast can a single proxied connection run between sites? Because now you're talking about machine-to-machine traffic, and a single machine-to-machine TCP connection can scale all the way to 1 gigabit speeds and is not mired by a PC or an application user. And lastly, and perhaps most importantly, the system to optimize traffic between data centers must have very, very low processing latencies, so that the optimizations that you're adding to your network, it adds no material latency to the overall workflow. So the port-to-port latencies must be very, very low, ideally in the tens of microseconds. So given the unique architecture and the feature set that the DMS carries, it is superior to the leading competitive solution on a number of fronts. I talked about some of them before. Let me call out some numbers to be very specific here. Of course, the DMS delivers the highest throughput of any WAN optimization solution in the market, along with the highest throughput on a per proxied connection basis. So the distinction between proxied and non-proxied connections is important, because if your goal really is to replicate at large distances, your replication traffic will run better if it is proxied. And the reason why is that endpoint stacks typically don't work well on high latency WANs, and they really haven't been optimized for those kinds of environments. I mean, even if they are tuned in some cases, they tend to not work well if there's competing traffic on the WAN. So really, our counsel is when you're looking for WAN optimization solutions for the inter-data center WAN, proxy solutions tend to work a lot better. I mean, some solutions out there, what they do is instead of proxying traffic, they add parity packets in the flow, and they kind of suggest that that's a good solution. I mean, that approach works well on satellite links, but really, it's not a good solution for high-speed inter-data center links. So if you have, satellite links, great, because you'll be losing packets in an orderly fashion. But if you're doing anything on an MPLS link or any kind of dedicated link, that solution does not work at all. I talked about the latencies before, so let me get a little bit more specific. Let me give you an example, actually. Consider a high-speed inter-data center WAN link. Let's say that's rated at a round trip time of 25 milliseconds. The replication engineers, let's say in that case, they've probably designed their entire workflows, and they've kind of focused on an RTO goal, which is built around this round trip time on the WAN. Now, if in this scenario, if I were to add a traditional WAN optimization solution, your overall RTT could jump from, it used to be 25. In the very best of cases, it could jump to 29, 30 milliseconds. And the worst case scenario is it could reach as high as 100 milliseconds in some cases. Now, that's not going to work, because all of your workflows are going to break because they were designed for 25 millisecond WAN latencies. Now the question is, how is that going to work? So with the DMS, the port-to-port latencies are in the tens of microseconds, not milliseconds, but microseconds. So when the DMS is deployed in the network, no measurable change occurs to the RTT, which means that you get the optimization that you critically need without needing to redesign your replication workflows. Now, this is very, very critical. I mean, the whole point of that optimization is to make things better. If you are going back and redoing all of your replication workflows just to make things work, that's not going to scale. I mean, you don't have time to go deal with that kind of stuff, right? So that's something that's very important, and we should all think about, the impact of port-to-port latencies. But, finally, and in some cases, more importantly, the DMS delivers the most value to the enterprise of any WAN solution in terms of the capex that you have to spend on the solution. With each DMS unit requiring a fraction of the power needed by the other optimization solutions. So with that, let me turn to the the use cases I talked about before and share with you the value that we were able to add in those two examples. So for the coast-to-coast high-speed replication use case that I talked about before, the DMS was able to reduce the WAN traffic by 78% and increase effective WAN capacity by about 5x. But most importantly for this customer who was unable to keep the replication workflows up and running at those distances, now they actually have an RPO that they can go after. Right? So their RPO, it went from whatever their goals were before, it went up by 60%. But again, they had no timeouts on their replication workflows, which was very, very critical for them because now they had some sort of replication in place. The other use case that I talked about before with the cloud provider, this customer, they were getting 20-30% effective utilization on all the links. Now they are able to fill those links by, they have an 11x improvement. So in some cases, on a 2 gigabit MPLS link, they went all the way to 6.5 gigabit. They used to be at 400-500 megabits. Now they're at 6.5 gigabit on the same link. So the percentage improvement on these links were so remarkable that the existing infrastructure, not only can they guarantee the SLAs to their customers that they wanted to, they can now go and sign up more customers. And really, for a service provider, nothing is better than that. Use your infrastructure and sign on more customers and get more revenue. So let me kind of close today's discussion by calling out that replication and backups, obviously, that's bread and butter for most enterprises. They're the biggest they're the biggest culprits. They're the biggest kind of application types on the WAN, but they're not the only types. I mean, there's some WAN, these same WANs that you use today for replication, they're increasingly being used for other applications such as live migrations of VMs, storage virtualization traffic, EMC VPlex, for example, and a slew of other applications such as big data. The WAN requirements are continuing to grow at alarming rates, and enterprise IT groups should seriously be looking at WAN optimization solutions for big traffic, right, at strategic infrastructure components. So to sum it all up, the DMS is the first and only solution specifically designed for inter-data center WANs carrying big traffic workflows. The DMS is the ideal solution to accelerate enterprise data protection initiatives. The DMS is the most scalable WAN optimization platform in the market, delivering the highest price performance and the quickest ROI of any competing solution. So let me stop there. Let me take a few questions, and if you have any questions, please use the chat facility and the Q&A facility in the GoToWebinar client and send them our way, and we'll pick a few and respond to them immediately. Okay, so let me see. Let me pick 3 or 4 questions here. So the first question is, I'll just read it out. So your competitors say that a standardized hardware platform is a better approach to WAN optimization. What's your take on that? So a standardized approach, a server approach on its own, it's for the use case that we're talking about, it's not going to get you anywhere. I mean, I guess the question is, what are they doing on top of the standard platform? If the competitor is basically rolling out, if it's a VM, if they're rolling out a virtual appliance on top of some hypervisor that's running on some Dell or HP or whatever server, for the application-specific use case, if you're deploying this to accelerate your SharePoint deployment in the cloud, maybe that's pretty good. That's going to work very, very well. But for the use cases that we talked about today, it depends. It depends, and mostly it doesn't work all that well. A number of our competitors have done this, the VM approach. Clearly there is a use case out there. But I think the way to think about the use case we're talking about, which is a high-speed networking problem, is let's ask ourselves the following question, right? Cisco, Juniper, Arista, Palo Alto Networks. I mean, these are companies that are known for high-speed networking, right? They don't have a VM-based solution for their forwarding planes, right? They build some, in some cases they used to do ASIC, and now they use some merchant silicon to build solutions. I mean, if you look at Arista or Palo Alto. I mean, the data center world is going from 10 gig to 40 gig to 100 gigs. A PC motherboard is just not going to cut it. If you're running a server, if you're running some, compute-intensive application, if you're churning a lot of data, servers are fine, VMs are fine. But if you have a system deployed in your data center core, sitting next to your Nexus 7K or your Juniper MX, right? That's not the right place for a VM. That's a place for a dedicated system which can really drive multi-gigabit traffic, and that's what we really built. We've taken a networking approach to building the system, and we absolutely believe that's the right approach. And proof is in the pudding. I mean, we're going out there, we're beating our competition because customers really understand that high speed is what's required for their RANs. I hope that kind of answers that question. I have a, okay, so the next question is, I have a 1 gigabit WAN, can you help? And perhaps this question is being asked because we talk about 10 gigabit a lot in our presentations and our content. So yeah, the answer to your question is absolutely. So the DMS scales anywhere from 1 gigabit to 10 gigabit speeds, and it can be deployed to accelerate traffic traversing, really anywhere from an OC3 to a 10 gig link. I mean, depending on your current application performance and the traffic type, you could make your 1 gigabit WAN really look like a 4 to 5 gigabit WAN without actually doing the bandwidth upgrade. And that's the phenomenal part. Don't change your infrastructure. We just make your 1 gig WAN look like a 4 or 5 gigabit WAN. And that's where the value comes from. And this is a very actually pretty common use case for us. So one more thing on that note. See, the way the system works is the performance on the system can be increased via software license. So today, for example, if you were to buy a let's say you have a sub-gigabit link and you end up buying a 2 gig license for the DMS. Tomorrow, if you upgrade to MPLS and you have multi-gigabit bandwidth available, you can just buy a software key and the system will just run faster. So the same system can scale all the way from 1 gig to 10 gig. You don't need to do a forklift upgrade to get more performance on our systems. Okay, do you accelerate branch traffic? So early days in the company, we chose that we're going to focus and we're not going to go after branch traffic. I mean, in theory, if you deploy our box in a branch environment, sure, it's going to accelerate things, but that's really not we want to focus. That's not our focus, and we're going to basically continue to focus on the inter-data center WAN use cases out there. Really trying to be everything to everyone only leads to everyone being unhappy with you. So we want to kind of focus on one thing that we do really, really well. Okay, so let me take one more question. Looks like we're at 11:30. Can your box be configured to not interfere with synchronous traffic? So the question is, if I have synchronous traffic on the wire, can you basically set it up such that your box doesn't really interfere with the synchronous traffic? Interesting question. So let's to start off, let's look at the key difference between sync and async traffic, right? I mean, really the difference is sensitivity to latency. Async workflows are designed to work with with larger WAN latencies and are okay with end-to-end round trips being whatever tens of milliseconds. But sync traffic, on the other hand, the typical round trips in say sync replication, 5 milliseconds is the absolute high bar, right? That's the challenge with sync traffic. Now the DMS, as we discussed before, the port-to-port latencies on the DMS when it's processing traffic or when it's accelerating traffic is going to be 100 microseconds or less. So you can do two things. You can deploy our box inline, and if any sync traffic is passing through our box, if you would like, we can accelerate that traffic. There's not going to be any overhead because our processing latency is a rounding error. We're going to add, say, let's call it 100 or 50 to 100 microseconds of latency depending on what's going on. That's a rounding error. But if many of our customers would rather be conservative, and at least initially, they would rather have the sync traffic pass through our box but be bypassed by the processing system. What you can do is you can set up a bypass rule for that sync traffic, and then just to take a sync packet in and push it out without processing it, the latency for that action is under 2 microseconds. So it's literally a rounding error. I mean, it's as if you went through a switch. So there is no impact of our system being in line in a data center and looking at both sync and async traffic at the same time. By the way, again, let me underscore the point that this is something we can do because of our low port-to-port latencies, but nobody else can do today. So 11:32. So looks like we're out of time. Again, folks, my apologies for the initial snafu with the audio. We'll be doing many more of these webinars. We're hoping to do one every 3 to 4 weeks. Please do listen in. We're gonna be good about learning the tool beforehand a lot more and do a better job next time. But I hope you learned a few more new things about us as a company and as a product. If you have any questions, let me just show you a couple of links here. There's a lot of resources available on our website. Please do get in touch with us via the website, or you can send us an email directly at sales@infinera.com and get in touch, and we'll be more than happy to answer any other questions you may have. Thank you again for your time. Looking forward to talking to you in about 3 to 4 weeks.